I think it's like he has to also stay.
Good afternoon, everyone. Now I'm excited to introduce two young open source contributors from the world of Bitcoin. First, we have Garima Dev, an intern at Summer of Bitcoin 2025, a teaching assistant at Bitshala, which is India's growing community at Bitcoiners. Alongside her, we also welcome Sayam, a design track intern at Bitcoin Tribe in Summer of Bitcoin 2025, contributing his creativity and design skills to strengthen the Bitcoin open source ecosystem. Please join me in welcoming Garima and Sayam.
So, first, let's start with some things that are difficult to change. Third parties controlling money that should be yours. Your currency devaluing just because we weren't lucky enough in the development race. People who are top in the power hierarchy can censor your transactions and monitor what you do. Do you see there is a problem? Is this how it should be? No, right? But what's the solution? It has been there in front of us for a long time. As the legend Hal Finney said, the computer can be used as a tool to liberate and protect people and not to control them. So, in 2008, Satoshi Nakamoto, an unknown identity, we still don't know who he is or whether he is a he released to the cryptography mailing list a white paper telling people about Bitcoin, solving a problem that researchers had been trying to solve for a decade about an decentralized, uncensored cash system, which is digitally transmitted. And in 2009, the first version of Bitcoin was released. And this is Hal Finney running Bitcoin. But does it work? Like, we see a lot of cryptocurrencies in our world right now, a lot of Web3 stuff. And, like, for sure, you have heard things like, oh, this is a scam. So, what's the proof that Bitcoin works? It's been working since as early as 2016, when Venezuelans have switched to an alternative. Like, their currency has been devaluing so much that, like, their bolivars is not worth anything right now. It's just like a piece of paper for them. So, how will their family members from outside the country send them money? One way that they had was to tell them to transfer the money to Colombia and then walk across the border to Colombia, bring back all the cash to Venezuela, which was dangerous. People can steal it from you and which was costly. So what alternative have they got right now? It's Bitcoin, because no one can control that. No government can censor that. You don't need a bank for it. It can just be in your Bitcoin wallet, which is in your mobile in a few minutes. So it's costless, it's convenient, and mostly you are free to use it. That's Venezuela. In Zimbabwe, he had a similar thing. Their currency devalued because the leader printed a lot of it. But his successors can't print more Bitcoin because it's set by the code. Every 4 years, you have a halving which decides how much Bitcoins a block can contain, new Bitcoins. So the government doesn't control how much Bitcoin is printed. Also, in countries like China, government can see how many transactions, what transactions you make on VPay, but they can't see what Bitcoin transactions you make. In Russia, the leaders can freeze the bank accounts of NGOs, but they can't freeze their Bitcoin wallets. In refugee camps, you have no access to bank accounts, you have no access to banks, but if you have an internet connection, you can receive Bitcoin and without any permission and without proving your identity. And it's working. And it's been designed to work for a century. Halvings greater than equal to 64, which we are supposed to reach by 2140. But still, why? Why would someone like you contribute to a scammy kind of technology that like people don't trust? Why will you want to do that? First, because the fact that there are less than 1% of people in the world who have ever used Bitcoin, and there are more than 50% of the people in the world who are living under oppressive regimes worries you. Because you still believe in the right to freedom which was promised to us in French Revolution in 1789. Because you believe that technology can change the world just like the steam engine did. And where does Oz come in all of this? A permissionless technology like Bitcoin needs permissionless contribution, permissionless development, which is done by organizations like this: Bitcoin Core, LDK, BDK, Stratum V2, PDK, and others. These are what make Bitcoin Bitcoin, along with some of the smartest people in the world, and maybe you, who put in the work, and with support from organizations like the Human Rights Foundation and Jack Dorsey's Spiral. But I'm still in college. What can I do?
So if you're still in college, we have a wonderful program, Summer of Bitcoin, where you can contribute to all those mentioned and all the other organizations that are not mentioned that are open source and contributes to Bitcoin. And we have two tracks in Summer of Bitcoin. One is developer track and one is designer track. So if you are a developer or if you are a designer, if you are a beginner and you want to explore both of those, you can try out Summer of Bitcoin. The program generally starts on February 1st. The application starts on February 1st. I'll show you the timeline. But first, why? So you can contribute to Bitcoin projects. You can explore BOSS. You can earn Bitcoin as a stipend, which is very, attractive. And you can also learn how Bitcoin actually works while building a career in Bitcoin. These are some of the experiences shared by the interns that interned at various organizations under Summer of Bitcoin. Then we have the selection process. The application period starts generally at February 1st till February 15th. So all you have to do is fill the application form. If you are in the designer track, you have to submit your portfolio. So you will get shortlisted. I guess there is no strict criteria, so it's very easy to start. Then we have a learning bootcamp that generally spans over a month, where we have kind of you have to study based on what track you are in, and then we have weekly assignments, all of which you have to pass week by week to cover to proceed forward. Then after 1 month of 4 weekly assignments, we have proposal round. This is where the main competition starts, because you now compete with all the other people and among all the organizations that you're targeting. So Summer of Bitcoin lists out all the organizations that are offering internships that summer. So then you have to choose those organizations based on your interest or your expertise and based on what the organization is demanding or what the project is basically. So the organizations list down all of those. You have to select top three, and you can submit proposals for at max 3. Am I right? At max 3, yes. You can even submit proposals for just one, but it's better to maximize your chances. So you now compete with all the other people that particularly apply to your organizations that you were targeting. So this is where the actual competition begins, and you have to actually make a good proposal of what work you will be doing over the summer. based on what the company is asking you to do. Then we have the proposal review period. Actually, the learning bootcamp is of 1 month, and the proposal round is also of 1 month, more than 1 month generally, 1 month 10 days. Then we have proposal review period, and the actual internship starts after May 5th when the results are released. And the organizations, if they wish, they can also keep an interview round to further shortlist the people from the proposal round. If you want to know specific details about design track, developer track, or what kind of companies that come, you can ask us after the session, where we are happy to share like what were the assignments, what were the. I can give you a rough idea. Like they were learning in the learning bootcamp, there were assignments related to mostly research the existing Bitcoin wallets. Find issues like UI UX issues, or you can find further you can suggest further feature sessions. Then basically it was more of a UI UX kind of thing with research. Then in the proposal round itself, the organizations that were listed in the design track mostly asked some asked for branding, their branding their new initiative or their existing project. Mostly asked for UI UX improvements, or just UI UX from scratch for the project that they were mentioning. So, what I have a suggestion for you guys is to at least go through the website, have a look at the resources mentioned on the website itself, read through the material, uh, practice some part of it. For design, you can polish your UI UX skills particularly. Not necessarily there will be organizations for UI UX, but it's better if you have UI UX knowledge, because that's mostly what's asked here. If you have illustration or branding knowledge as well, that works, because they look for all-rounder candidates. Yeah.
Sorry.
Uh, Before we go to this slide, since I was in the developer track, I can add that in the learning bootcamp period for developers, we had assignments every week, and they basically tested if you knew the technical details of particular things, like how do you create a transaction, how do you mine a block. You had to program all of that, and the right materials were shared before time. So these actually depended more on your programming ability than your Bitcoin knowledge, because the right resources were always shared. So, and if you have any questions, you can ask like one of us after the talk. And there's one more thing, like for people who are not in college anymore and they still want to contribute to this revolutionary technology, and also if you are a college student and you like still find time out of your courses in order to contribute, there is an organization called Bitshala. It's actually a community of Bitcoiners, Indian Bitcoiners, following along the lines of Vinchum in Brazil and We Trust in Africa. They offer fellowships and charter grants to people who want to work in this space, provided you have a proof of work, which is showcased by joining one of their clubs, which are free of cost, and uh, they usually involve going over a certain material and then like establishing that you know how Bitcoin works. And then there are events that you can join if Bitcoin interests you. You believe that your money can be better, then there are some events for you. Before that, there's a this QR code for the Bitshala Discord link if you want to scan it. Any? Yeah, so finally, we'll be having this summit in Goa this November, and we'll have speakers from all around the world, Bitcoin developers, Bitcoin designers. So, if Bitcoin is what values to you, you think Bitcoin is the future of money, please join us here. And if you are one of the, like, you are from ITK, then Bitshala is offering two students from the college to attend this event, like they're sponsoring it. So do let us know. Thank you.
Thank you, Garima and Sayam, for sharing your journeys and experiences with us. Your passion for Bitcoin, open source, and community building is truly inspiring, and we are grateful for your contribution to OOSC 3.0. Let's give both of them a big round of applause. पीछे करना
उसको बुला ले उसको
वही बुला रही हूँ
उसको बोल के वहाँ पर उसका इंट्रो दे दे थोड़ा
वो है
वो बैठी थी वहाँ पे सारी बात
पर है कौन वो मतलब क्या करती है
कुछ नहीं ऐसे बोल दे आई का नाउ आई कॉल विद इशू ऑन स्टेज विद दिस हर प्रेजेंटेशन अबाउट बुला ले बुला बुला ऑन है कर दो अभी होगा चल ऑन बैठ
Thank you. And now I would like to call upon Vidushi Sharma for presenting her presentation.
दैट्स ऑल आपका प्रेजेंटेशन
नहीं
आपका कौन सा प्रेजेंटेशन है
accessibility.
आप के नाम से आया हुआ ना मेल
मैं देख विदुषी
सर्च कर
हाँ
नहीं फॉर्म वो तो फॉर्म है तो
ये स्ट्रीम हो रहा है पूरा एक मिनट
हटा दे
अब देखो
एक काम करो ना वापस भेज दो क्योंकि अगर आप इसको बोल के ओएससी पे करवा देगा
हाँ
उसको मेल बता देना उसको osc2025.team@gmail.com बताया था कोई ईमेल भेज दिया
हाँ भेज रही हूँ मैं तो मैंने अभी ईमेल लिखे होंगे वहाँ पे
सुन तू एक काम कर एडिटिंग जा उसका बोल कि सिद्धार्थ को क्या बोलते हैं बोल दो कि इसकी कितनी देर 40 मिनट रहना इसका टॉपिक
हाँ इसका तो
हेलो
इसका
तो सिद्धार्थ पर को क्या बोलना है कि सिद्धार्थ बट शायद मेल कर रहा है कि मेरे को देख रूम का रूम का
आगे यस आ गया यस
यहाँ पे भी सही चलता है मिल गई
हाँ मैं इसे डाउनलोड कर देती हूँ
ये ले
अभी मतलब हमें लगा देती हूँ जब होता
पकड़ कर
हाँ
तो देखो
हाँ फिर से देखती हूँ जस्ट मैं सेटअप करके करती हूँ जस्ट अ सेकंड ये हो रहा है क्या
Okay. So my talk is about Bitcoin design and accessibility. And in accessibility, there are 2 points that I'll share, like I'll cover. That's color contrast and color independence. Okay. So hi everyone, I'm Vidushi. I'm a UI UX designer, and I've been designing since 4 years now. I discovered Bitcoin, I think, 2.5 years ago, and I'm contributing there since then. Okay, so first of all, how Bitcoin design is different from traditional design jobs. That first thing is environment. It's open source, it's decentralized and permissionless. You can just go on and start contributing like now. So, and it's decentralized. You don't need to like. There's no central authority, so you don't need permissions or just report to someone. Then there's ownership. So designers can directly shape products that anyone can use. So as you start contributing, you can just go on and see what project needs you, and you can just create it, and anyone can use it there. Scope of work, like design for money, freedom, and global access, like said in the previous talk. There are problems with money, and we need to solve it. Then the process is very collaborative, transparent, and often we async in public. So as it's transparent, you can just go on and, as I said, like you can just go contribute, and people will find you. They would like to contribute. Like you can collaborate with them. And it's also said that in Bitcoin, there's no competitors. We are collaborators. Next is constraint. So the must balance usability with the security and privacy. In traditional job, it's mostly aesthetics and business. And here the priorities are security and privacy. Next is users. So there's global and diverse users. And for user testings as well, you can go global, like the users would be global. So you can user test your apps or your products with global people. And the impact is you can influence financial empowerment, as said, and access to money and human rights. Recognitions is community driven. Yeah, so we have communities. For design, it's Bitcoin design community. You can actually have put a QR scanner there, but yeah, you can just go on and type in Bitcoin design community, and you'll find the community, and you can just join the Discord and start contributing there. And your contributions are visible publicly, so no credits taken by anyone else. And the career path here is non-linear. Like in traditional job, it's mostly linear, like you get promotions and formal like job titles. But here it's mix of volunteering, grants. You get grants, design grants as well, and on your independent projects. So you can work on that as well. So yeah, now I'll dive into how to make it more accessible. So what's accessibility? First of all, it focuses on enabling users with disabilities to perceive, interact, understand, navigate tools and services and products that they can contribute equally without barriers. So yeah, these are the three things: accessibility, inclusive design, and usability. So these all three falls under the same tree. How they are different is accessibility mainly prioritized people with some disabilities or impairments, and inclusive design is mainly like we should include everyone, like age-wise, gender, and culture. And all this falls under the same tree, as I said, usability. Here, you can see the diagram. Okay, so I would need some interaction here. You guys have to raise your hands, that's just there. So, okay, how many of you think that a person with, like, sitting in a wheelchair, like this person, is disabled? Only three? Okay. And who thinks that a girl with a broken hand is disabled? Okay, same guys. No one else thinks that they are disabled guys. Wow, good. And who thinks that this woman with grocery bags is disabled? Okay. So they all are disabled kind of way. So there are 3 types of disabilities. It's permanent, temporary, and situational. Here it's situational. So this is a like screenshot taken from Microsoft Design Toolkit, inclusive. Here you can see how they are. There are different types of disabilities and see, touch, hear, speak. Like so, touch is like if there's a new parent, he's holding his child, and you have to use his phone. So you might have seen that there are accessibility settings in your phone as well. So you can do that keypad thing on one side so that it's more in your thumb area kind of a thing. And C is like distracted driver. Here is like a bartender, or speak is a heavy accent. So also the captions that you all use today were made for the people who couldn't hear, but you all get like you all use it today, right? For YouTube videos, Netflix, right? So accessibility doesn't only means like designing for disabled people, it makes your experience better as well. So why is it important? Like 16%, that's 1.3 billion people of world's population have some kind of disability. And like, yeah, as I said, disability is not just someone with a broken hand or in a wheelchair. It can be like you guys are wearing specs, right? You would need a larger font size or something. So that's that's also there. Also, there was this survey done in Netherlands, and it was how many people have their accessibility settings on their phones. And yeah, this was iOS and Androids. Almost half the people had some kind of accessibility settings on their phone as well. So yeah, you can go take a look at it. There is full stats, visual, audio, everything. So this is APPT. You can go and check it. Okay, so let's begin. What things to keep in mind while designing? So first one, like I said, color contrast. It's a ratio of contrast between things. So to be accessible, there should be an adequate contrast between the color of a piece of information in the foreground with the piece of information in the background. And the contrast I'm talking about here is, sorry, the ratio I'm talking about there is 4.5:1. You'll know what it is. Okay, interaction time again. So do these pass or fail? Okay, how many of you think that the red one fails the accessibility test? Like the ratio thing. Okay, and the green one? Okay. So let's find out. So how to know? We divide it into 2 categories. First is information bearing elements, and the second one is decorative or disabled elements. So the text, the images of the text, and the standalone icons come under information bearing elements. So you can see like the yellow on black, that ratio, like background and foreground should be 4.5:1. How to check? I'll go to that. So yeah, it should be 4.5:1 that. And the exception is for larger text. So that can be 3:1. So for example, that board all of you can see, right?
So actually, many people wanted to join the talk,
Okay.
your talk, but it was scheduled in L18. So people don't know that talk is going on right now.
Okay.
So I don't know who switched the talk because it was in the L18. So can you just wait 5 minutes? I'll text the participants and they'll join. Then you can continue.
So I have to give it again, like from the start, right?
At your wish.
Okay.
How much time has passed?
Not much. Not much. Not much.
Did you request like this room? Alright.
No, I didn't. He said that it's shifted here. Huh? That's okay. No, she's saying that there are more people who want to join my job. So should I go there?
Yeah, that is what. फिर यहाँ वाला
I don't know. These people come.
एक बार ग्रुप पे डाल देती हूँ लोग जॉइन करेंगे 5 मिनट वेट कर लो ऐसे ग्रुप पे डाल देती हूँ लोग ऊपर ही करेंगे Till that time, does anyone have any questions?
So many people wanted to join this talk, and since it was abruptly shifted, so people aren't able to join right now. So we'll wait 5 minutes. I'll text in the group, and then we'll continue.
And since you have 5 minutes, I would like to answer any question from the previous talk or this 1 minute you can take. What do you think of money? What is money?
No one? Anyone wants mic?
They can speak. You got a book to read? Anyone? What do you think of the thing that you've been running after your whole life?
If you have any friends who are interested in this talk, then you can just call them.
No one? There is one idea that I like a lot, is that money is a way to transfer your hard work over time. So when I think of money that way, inflation worries me. All the effort that I put in today to get a rupee will have no value after 20 years. Isn't that the reason why we are like running after investment strategies?
Yes.
So don't you think that this thing needs a solution? We need a better money. Like earlier in previous times, like we used to have gold or silver kind of coins to be used as money, and those had like obvious problems. Similarly, and then we brought this digital cash system and all. This cash system and all means everything cash systems. So there was a problem and we tried to solve it. And like we have a solution right now to what? To the problems that we are having with money, with our current money. So what is the reason, like, what do you think about Bitcoin or in fact any other cryptocurrency?
If you want, we can move to a debate.
Okay. But these people
What do you want?
it's okay.
Actually, more people are waiting for you in LAT also.
Okay, do you guys want to shift to LAT for this talk?
We can't forget.
There are many people
Okay.
waiting for this session.
Okay.
That's why we are shifting.
Because 8 seconds. Okay, okay. So we still have time. What do you think? Like you must be hearing about these terms: Web3, blockchain, Bitcoin, Ethereum.
Even then there are more like wrong answers. We can answer.
Are anyone of you interested in this talk? Then we can move to LAT. दे रखा जो टॉप यहाँ पे माने मतलब देख बताओ कुछ और हो रहा है तो पहुँच तो डायरेक्टली वो भी अपनी मर्जी से कुछ भी कर दे रहा है बहुत सारे क्यों लग रहा है जब शेड्यूल है तो और कोई भी किसी को कुछ भी माने एकदम ऐसे या संक्रांत कंफर्म कर अभी किसको है? लक्ष्य नहीं आ रहा है। 9 को तुमने स्टार्ट है 25 में ना हमारे के साथ
क्या करना है इसको? मेल भेजना है इसको?
क्या
इनको मेल भेजना है।
स्ट्रीम पे बता दे स्ट्रीम पे बोल दे कि शिफ्ट कर लेंगे तो
The venue has been shifted to room 1. You can join room 1 from our channel.
Hi everyone, hope you can hear me right now. So
Yes, Lakshya, we can hear you.
great. So today's topic that I'm going to be discussing with you is going to be harnessing the swarm, a practical introduction to open source AI models. Uh, can you see my screen right now?
Yes, Lakshya, we can see.
Great. So yeah, this talk is just going to be a very high-level overview of the current open source uh, machine learning models that students can get started with, learn with, and understand how they differ from the proprietary services that we've been using all along. So I'll start with a little bit about myself. I am from the same college that all of you are sitting in right now, IIT Kanpur. I'm a 2016 batch student, graduated in 2020. This is a photo from our convocation, and it's me on the rightmost. And right now, I'm a senior software engineer at Google Search. So here we work on helping Google Search clients, verticals, adapt their machine learning models, fine tune them, and be able to serve millions of features across our services. So, yeah, this is a little bit about me. And I think all of you are sitting in a lecture hall 19 or a lecture hall like that. And I have very fond memories of those lecture halls, especially the fact that they're probably the most comfortable seats and the most ideal ambient temperature for falling asleep in the middle of a lecture. So I won't mind if you guys do that, but I hope not. So let's go ahead and talk about more about the topic at hand. So yeah, introducing open source AI models. We talk a lot about large scale AI models. We talk about ChatGPT, Gemini, Claude, and we discuss these proprietary systems all the time because at this point we understand what we can build with these applications. But what does not gain that much of traction, that much of attention, is the open source AI movement that's also developing alongside the proprietary AI space. So let's just look at how these two areas differ. And yeah, proprietary systems are typically controlled by large corporations, and access is limited through paid APIs. And you don't have any visibility into these models except for the fact that you can use them as advertised by these companies. On the other hand, the open source AI movement allows uh, the freedom to inspect, modify, and distribute AI models. So you're able to see the model weights, you're able to fine tune the models, host them locally, and modify it to your own use cases, expand on that, and build new applications, new models on your own. But uh, there are a lot of differences between these two, and we'll go through that. But what is often overlooked is that the proprietary space and the open source space, it's not a battle, it's a symbiotic relationship. The first revolution that happened in recent time around the space is the attention is all you need model by Google DeepMind. And that model was an open access research paper. So very much aligning with the values of open source. And that spawned the whole transformer revolution. OpenAI used that model and built ChatGPT. And the whole transformer architecture is what is spawning all the use cases that we see today that change our lives. Now, even though we talk about these proprietary models, we also see a lot of these open source models come from these same companies that build these uh, proprietary models. So Meta's Llama 3, Google's Gemma 3, OpenAI's open source models that they've recently announced, Grok, Grok 2. Now, the way this works is that these companies, whenever they release a new version, they take a very older version of the same AI service and they release it in the open source world. So it often lags, but it always offers new opportunities for understanding how these companies think and what makes these great models. Alongside that, there's the DeepSeek R1 and the Google's Gemma 3, which is state of the art, which is the latest and greatest when these models came out. And so, not just catching up is what open source models do, they also lead the way in a lot of ways. But yeah, to give a brief overview of how these things differ. With open source models, you get a lot of free to use opportunities and a lot of access to the code, the model weights, control over the data, visibility over the aspects of training, and security vulnerabilities. So this makes it much more easier to understand and ethically verify an open source model versus a proprietary one, which is hidden behind subscription fees, which requires licensing, which is limited to vendor-provided APIs. And most of these services are very loosely defined in terms of what model they're serving. So you're opening GPT-5 and you're opening basically ChatGPT and you're issuing a query. You don't really know which GPT model it's going to go to. So these companies do try to minimize costs and limit access, whereas with open source, it's much more well defined and you have much more control. Now we do see a lot of these applications in the closed source area, not just in typical LLMs, but in other applications like image generation, music generation. But we don't see a lot of those noise in the open source world. So let's just take a brief understanding of what the landscape has in the open source area as well. So let's talk about image generation. So this one is, I think, the most popular application, Stable Diffusion. It is a highly customizable unit-based architecture, which is used to generate and modify images. And this, I'm sorry about the typo here, but often beats leading image generators like Midjourney, is what I meant to write. So basically, Stable Diffusion is a state-of-the-art architecture when it came out. It has spawned so many startups. Even a friend of mine is doing a startup that's built on top of Stable Diffusion. So it allows so much customization. There's this UI that I've linked here, the Comfy UI, that allows you to tune so many aspects about the generation of your own use case, that it provides so much control and flexibility for you to build something great, both as a beginner who's just using Stable Diffusion to generate images, and as a pro who's trying to understand what goes on under the hood and tries to make tweaks to whatever layer that you can. So again, the open source realm is full of success stories like these. And I'll talk about music generation because it's something that I've tried out a lot. And one thing here, it's not just about the open source world. Music generation is something I think not a lot of people have tried that hard, because it's so good at this stage that I like. In my free time, I also like to shoot short films, and this is one short film that I shot, and I had a song in the middle of it. I'm not sure if you can hear it. Sorry. दोस्तों के साथ सपनों में सो गए खुशियों में. So this is a Bollywood kind of a music video, and all it needed was a very small prompt, and I was able to generate a Bollywood style song in Hindi in minutes, 1 minute or 2 minutes. That's how good music generation is today. And while this is generated using Suno, which is not an open source model, there are a lot of other up and coming applications. So there's Meta's Music Gen, which is one of the older music generators, but I've gone through this code base and it's such a great learning experience if you want to understand how to tokenize audio and how to generate music. So this is great for all non-vocal use cases and very easy to access. It's available through the Transformers API. It's available through hosted services, and I definitely recommend giving these services a try. And then there's another thing that I read recently was the Diff Rhythm paper, which is building on top of the existing tech, and this allows you to create very natural sounding songs with vocals as well. So there's a lot of innovation going on in the music generation space too. Then talking about general purpose LLMs, there are a lot of names that I could have listed here. I've listed Llama 3 for now, which is not the newest, but still one of the best general purpose LLMs out there today, with a massive 15 trillion token data set and very good instruction following and reasoning abilities. So yeah, there's very little that you cannot do with open source AI today. And I highly recommend trying these services, understanding the environment, and making the most of what you can and building on top of them to bring so many great applications that are yet to come. So this was all about understanding the current state, the landscape, how AI models differ in the open source world versus the proprietary world. Let's go deeper into how you can start working and running your own first open source model. So even though this might seem daunting to run an LLM locally, I'm sure a lot of people here might have already tried the Transformers library and done this. So Hugging Face Transformers is a great library that provides so many pre-trained models and tools for various AI applications. And whichever open source models that you are trying to read about, learn about, whether it comes from a big tech company or from a small project, a passion project, it's highly likely you'll find it on the Transformers library. And a very simple use case for trying to generate a GPT-2 output is 4 lines of code, 3 lines of code really, where you simply provide a pipeline, which is a construct in the Transformers library, mention the model, mention the task as task text generation, and you can simply generate data, generate a response for a given input, just like that. So this is how simple it is to sort of start using these libraries and trying to then build on top of that to achieve even more. For example, today all AI applications are either prompt oriented or require some kind of fine tuning, which is something that's become so easy to do that I saw this video recently, and it's about taking a llama model and adding low rank adaptation on top of it to fine tune it and perform a task. For example, in this, I think he talks about uh, you take a language model and you fine tune it to answer questions with the persona for pirate without even putting that in a prompt. So even though prompt engineering today is so good that you rarely need to fine tune models for general purpose applications, this video will give you a very good idea of how to add new techniques like low rank adaptation. Then I'm sorry about that, but yeah, you can use these libraries to try out and understand how you can go ahead and basically run and fine tune your open source applications.
Hello, everyone.
Sorry about that. Yeah. So basically, yeah, this is mostly all that I had to share today. And it's a very high level overview of just exposing some of you to uh, all the great things that you can do with open source today in the AI world. And hopefully, I get to see a lot of things that you do and post on Hugging Face, GitHub, and build great applications out of it. That's it. Thank you.
Thank you, Lakshay, for your insightful talk. Your experiences and perspective will surely inspire many young developers here at OOSC 3.0. We truly appreciate your time and contribution. Let's give him a warm round of applause.
Thank you so much. This was a great experience.
Next, I'm delighted to introduce Mr. Dipankar Shuge, currently a space fellow, class of 2027 at IIT Kanpur, and a CSC graduate from NIT Durgapur, class of 2024. He has been a FOSSEE 2023 contributor and a finalist at IICC 2022, and is an active front-end developer with a strong passion for open source and innovation. His journey reflects consistent excellence and dedication to both technology and community. Please join me in welcoming Mr. Dipankar Shuge. Dev.
This is bad to stage. Sir, sir, so you can use this. Wait, just
Yes.
So, good afternoon, everyone. So, before I begin, I would like to ask, okay, there are a few participants, anyways. How many of you are from mechanical engineering? What are your backgrounds, anyways? Computer science. Okay, that's nice. So, my project here that I'm going to present, it deals with both mechanical engineering and computer science both. So, before I start, I would like to state a few words about FOSSEE itself. So FOSSEE is an organization based in IIT Bombay, and we are sponsored by the government of Ministry of Education, Government of India, and our majority of the work deals with promoting the usage of open source softwares in academia. For example, in computer science itself, you might have gone through electronics lab in your second year, and for that you might use paid some paid simulators for your softwares. So instead of those paid simulators, we promote the use of open source softwares like eSIM, and in place of MATLAB, we can also have Scilab and all those. So you can also contribute to FOSSEE by going to the websites. We have internships and fellowships around the year. So I will catch on a bit about that in the end. So moving on about the main projects, Venturial over here. So Venturial is before I start about Venturial, so I would like to introduce you about the term CFD, computational fluid dynamics. So it is a field inside mechanical and aerospace engineering where you use software to make fluid dynamic simulations to study how a fluid can flow around any given object or a mesh. So there are specialized softwares for that, and to develop those softwares, obviously you need computer science engineers, where people like us come in. So Venturial is basically a GUI software for another CFD software called OpenFOAM. So OpenFOAM is a CFD software where you can do CFD simulations and everything. But the caveat that comes in is that many of the OpenFOAM itself doesn't have a GUI, unlike other softwares in its kind, software such as ANSYS or anything. I think you might have heard about ANSYS or AutoCAD. So those softwares, they have a huge company backing them. They have a proper interface and proper solvers. So OpenFOAM doesn't have a huge company backing them up, so they are only a package of software that can be accessed via command line interface. So for mechanical engineers, it's a bit cumbersome to use it via a command line interface. So that's where our project Venturial comes in. We try to provide a environment where it is easy for those mechanical engineers to use OpenFOAM by giving them basically a GUI interface. I will demonstrate a few. I will show a few screenshots of the interface itself. And but that interface also, it helps you while you're starting up. While if you get used to the software, you realize that okay, CLI gives you more control. So for that, we have PyVNT, which is a Python package that helps you to abstract and manipulate OpenFOAM data inside of Python. So let's say if I want to simulate a mesh where let's say I'm trying to simulate a square pipe where my pipe's width is increasing by 10. So if I want to write that in a text file for the OpenFOAM cases, it will be a long time. So I can just script it in Python using PyVnt, and I can just let OpenFOAM do its job. So moving on, as I said, the motivation mainly. So first of all, in OpenFOAM, if you want to make any case files, you need to write long text files, .txt files. So that is basically very much time consuming. So our software Venturial generates that files for the user. Secondly, you are in CFD simulations like this, we are dealing with objects, 3D objects, which are meshes. And when you're dealing with 3D objects, it's always better if you can visualize an object in yourself. So when beginners start out using OpenFOAM, it's pretty difficult for them to visualize that shapes and everything. So having an interface also helps with visualizing those shapes. That's where we again come in. Then these two obviously, lower the learning curve for the beginners a bit. And also, one might argue that there are many softwares in the market right now that already does all those things. So, for example, there are some softwares called Visual Foam, which is a web-based UI for OpenFOAM. I can just make an entire OpenFOAM simulation from the web itself. So, why our software? So our software aims to give a homogeneous environment for the simulation so that the user doesn't have to shift many softwares for many things. So if you are familiar with CFD simulations, there are mainly three parts of a CFD case, such as meshing, solution modeling, and post-processing. So OpenFOAM comes with a very good post-processing tool called ParaView. Other than that, we do not have many good meshing and solution modeling tools. So there are good meshing tools, there are good solution modeling tools, but there are no such tool in the market which is free and open source that offers both of them under the same roof. So we aim to provide that environment for the users. So current features of Venturial is, a little word about Venturial before that is that the effort that goes behind the development of Venturial, it is done mainly by students from different engineering background. So I myself, I started contributing to Venturial after my BTech was done, even sometime during the final year of my BTech itself. And others who are contributing, the interns who have worked under me, they were also second and third year BTech students. So it's mostly a student-driven. It's mostly a student-driven endeavor, and for students to develop a full-fledged software that can handle 3D mesh generation and everything, that is a tad bit difficult. So the approach we have gone with is we have taken a very well-known software in this arena called Blender. You guys must have heard about it. And we have developed a Python add-on for Blender so that whatever mesh we make inside Blender, we can just extract the data from it and translate the data so that we can be reused inside OpenFOAM itself. So that's what I've given here. So inside of OpenFOAM also, there are some meshing tools such as block mesh, snappy mesh. So we have capabilities of using both inside of a Blender add-on right now. So here are some screenshots over here. So in this one, you can see that I have created the pipe mesh inside of Blender. So this may look like a square pipe, and here are the modified edges. So this helps you so if a user comes from an OpenFOAM background, if anybody knows what OpenFOAM is, they would instantly recognize that, okay, these are 5 blocks, these are the modified edges of the blocks, and this entire mesh makes a pipe. So that is how it works, and this is obviously inside of Blender. So if you have used Blender, you might recognize this interface. This is an example from the latest Snappy Mesh UI, where this is basically this blue box over here is the domain in which my simulation will go on. And I have just put a monkey head over here to say that I can just make any custom shape and then have it simulated inside of our add-on. So this makes it really powerful for users because once again, users don't have to rely on another software to make a mesh and then switch to some OpenFOAM case generator to generate their cases. So here you can just make your model inside of Blender itself, and then using the add-on, you can just generate your OpenFOAM case file and then run it inside OpenFOAM itself. So that is a very big plus point for OpenFOAM. And other than that, we are also working on a node-based solution modeling interface for inside of Blender. As you know, that Blender's node interface is quite powerful. So unfortunately, I do not have any screenshots for that. It is under development. Moving on, there is another project called PyVNT. So a bit more on that. The PyVNT stands for Python Venturial Node Trees. So let's say so Venturial is mostly useful for new users and for instructors who are trying to get new users on board. So let's say if I have an advanced user who wants to, let's say let's say include scripting in their OpenFOAM cases. So they can either use C++ to script their own case files. It can be a bit difficult sometimes. And let's say if they want to get more freedom on their scripting, then they can use PyVNT. So PyVNT has two main benefits about that. One is, of course, it allows the user to script their own uh, case files. Another one is, let's say we at IIT Bombay at FOSSEE, we are just a small team. We are making this UI, and this is our small effort. If in future somebody else has a better idea of an UI, so let's say let's say somebody saw this UI, they used it, they did not like it, but they like the approach and everything, and they they want to build another UI based on their own 3D mesh, 3D modeling software. Let's take FreeCAD for instance. FreeCAD has CAD modeling capabilities also, unlike Blender. In Blender, CAD modeling is a pain. So let's say if I want to make an add-on in FreeCAD as well for Venturio. So PyVNT makes it easy for them, because PyVNT in itself is a Python package. I can just read and write OpenFOAM data from a Python package itself. I can just call a single function. Let's say pyvnt.read. I can just pass a case file, and it will generate me a Python tree containing all the data of the text file inside OpenFOAM. So I have an example right here. So this is a very small solution modeling file over here. So this is how it usually looks like. So here we have solvers, and inside of solvers we have a few dictionaries. I just included one here. So this one is P, which is the initial pressure. And to solve the initial pressure, I have some parameters over here. Let's say I'm using these solvers, these solver parameters. I myself don't know what this means because I'm from a computer science background. Any mechanical engineer over here might be able to understand what these mean. So now if I want to port these into Python, I can just get my PyVNT to read that file, and it will generate me a node tree like this. So node solvers is a parent node, then P is a child node, and inside P, I have these attributes that can be modified. And this node C, key C, enum P, these are all different classes that are used to abstract the OpenFOAM data. So if you visit the GitHub, you can find more info about these classes. And because my time is limited, I haven't included much about it. And inside of PyVNT also, one of the recent projects that we had was using an LLM to parse OpenFOAM case files and then generate the PyVNT node trees. Because once again, one of the challenges we were facing was that reading PyVNT OpenFOAM case files using a normal parser, it was proving a tad bit difficult because our project is based primarily on Python. And parsing a text file using just Python is very resource intensive. So what we wanted to check was that, okay, can we use a language model? Because language models are very good at understanding languages. So we did that, and turns out the results are pretty similar, but in the end, a normal parser would prevail. So we have moved on. We moved on with that itself. Maybe in the future we will include the LLM for some more things. Maybe a AI chatbot to help new users get on board with 520. But that is the basic curves of the thing. If any computer science engineers are interested in contributing to PyVNT or maybe OpenFOAM, or maybe they want to try this out, they are more than welcome. So that's it mainly for my talk. Here I have included the GitHub links for both. If anybody wants to check them out, you can check them out. And if you want to contribute, you're more than welcome. If you're also looking for internships in this matter, you can also reach out to us in the following email IDs, or I'm also available on LinkedIn. So if you have any questions, where I will be happy to answer, or otherwise that's it for me. Okay, thank you.
Thank you, Diptanshu, for sharing your experiences and insights with us. Your journey through open source research and development is truly inspiring for students and young developers here at OOSC 3.0. We greatly appreciate your time and contribution. Hello, Shua.
Yes.
Yeah.
Okay. I'm selecting the right screen here to share.
Yes. Uh, you can upload your PPT here.
Oh, oh, yeah. Can I share my screen?
Uh, no, you have to upload your PPT here, then only you can. Yes, you can share your screen. You can try doing
Okay.
that as well.
Okay. So yeah, I have the screen shared, and is that looking good?
Uh, I cannot see any screen.
You cannot see any screen. Oh, I can. Oh, okay. Okay. All right. Showing me that it's sharing the screen. You're not seeing that at all.
No,
I
not,
have the
not
PDF uploaded. Do you want to use that?
Yeah, sure. Yeah, it's showing. Sorry, it was. Yeah.
Yes. Okay.
Is
Okay.
this the
Cool.
one?
Perfect. Yes. That's really what I'm looking for. Okay. I'm ready when you are.
Okay. Yeah. It is a true honor to introduce Ms. Shua Khan, a Linux fellow at the Linux Foundation. She is a leading figure in the Linux community, well known for her extensive contributions to the Linux kernel and her role in strengthening the global open source ecosystem. Her work continues to shape the technologies that power systems worldwide. We are truly privileged to have her here with us at OOSC 3.0. Please join me in welcoming Ms. Shua Khan. Over to you, ma'am.
Yes. Thank you very much for the introductions. I am presenting today from USA. I am going to talk about kernel testing frameworks to begin with, and I have one more session. So really what we are going to talk about is there are two kernel testing frameworks in the Linux kernel. And these frameworks allow us to develop tests for our kernel in the kernel Git tree instead of relying on external tests. So this allows us to do two things. One is when we are, is everything okay?
Yes, ma'am. Everything's
Okay,
fine.
okay. I was hearing chatter to see if everything's okay. So that allows us to do two things. One is when we are developing new features and making changes to an API, existing API, and so on, we can develop tests at the same time and have the tests and the feature itself reviewed at the same time. So it is I'll talk about K-self-test first. K-self-test is, as the name implies, it is self-test for the kernel. Self-testing means that we are able to test the kernel from within the kernel. We have all of the tests in the kernel source tree. It is a regression test suite, and it has a closed and open box tests. If you are familiar with these terminologies, closed usually means that user does not know, the person running the tests doesn't really know the internals of a piece of software. Open means that internals are known to the developer of the tests, and they can tailor it to test specific features because they know what the internals are. So usually unit testing falls under open box tests, and closed testing where, say, you are going from the application space and then you're using the feature as an application, user space application would use. This case of test kernel from user space, and you will have C programs, a mix of C programs, shell scripts, and kernel modules as well. We load the kernel modules and test. So can I use a K-self-test? One would ask. In that case, what you would do is it allows for, it's not for workload or application testing. It is for coverage, error paths. You can cover different various error paths. For example, you are making a system call. You can feed it different kind of inject errors through your program, pass invalid flags, and so on. See what would the result be? How would kernel behave in that case? So one thing is it is perfect for functional and regression testing. So when we find new bugs in the kernel, we add a test for that so that we don't encounter the same thing, and we are continuously testing for that. So regression testing of kernel. Focusing on regression testing and of subsystems, bug fix. When you are fixing bugs, we'll write tests for that. Testing for APIs, system calls, critical user paths, and then common use cases. Those are the kinds of things. So it's a perfect end-to-end regression test because you are testing a opening files kind of thing. You can test exhaustively whether as a root, do you have privileges and you can open. As a user, you shouldn't have privileges in some cases. You shouldn't be able to call certain flags, pass certain flags into a system call. Those kinds of things you can test. So it gives a quick assurance that everything works. So what we would recommend is we usually say, hey, if you're a user, if you upgrade it to a new release, go ahead and then run a test. So you can check that link out. That has a kernel validation case with K-self-test slide set that's open public, uploaded to kernel wiki. So the second framework we have is KUnit. As the name implies, it is a unit testing framework. What we can do is we can add unit testing. All of these tests can run as the kernel is booting up. So it is a in-kernel testing, meaning in the kernel as it is booting up, it can test various things. It will test internal kernel APIs as opposed to external, meaning external to not user visible cases. K-self-test, you can't quite test that unless you write a kernel module and load that and test it. So this helps us, KUnit framework helps us to not have to go through that step and also invoke tests internally in the kernel API. It can test libraries and drivers, as opposed to driver testing can be difficult. Testing, meaning writing tests for the drivers, can be difficult with K-self-test a little bit. In some cases, KUnit allows that, and it can individual unit testing also is possible with this. Perfect for unit testing, really. I mean, as the name implies, makes it easy to test and edge cases and such. It is a suite of open box tests, and we keep adding a lot of tests with each release. We keep adding tests to cover the 2 million plus lines of code we have, and it is an ongoing task. So you can look at this K-unit testing strategies. It's a webinar, actually. Even the previous one is a webinar. You can take a look. We have a webinar, several webinars on the LF live webinar series. So you can check those out. These two are part of that. And let's contrast the two. People ask, hey, when do I want to use K-self-test for two reasons. When do I want to run it? And also, is K-self-test or K-unit right for me? Which one is right for me to write tests? So there's two angles to it. Good. So K-self-test is like good for testing coverage in deeper code paths, right? So good for testing commonly used code paths. It also a good test some error paths. It has multi-architecture support, and K-unit is initially when it came out, it did not have multi-arch support. UML is default for it, but we have been expanding it, so it can test several architectures now. So in K-unit. So K-unit is good for targeting error paths and edge cases, easier for faster and zeroing in on a kernel area. For example, you want to just say, hey, I want to test DMA, for example. You can test that. You can say, I want to just test XFS file system. You can test that. You can enable those and test it. So is K-self-test really, but it is unit. Both can be used to target an area, run targeted tests, and K-unit can also do the same thing. And K-unit supports multiple architectures, x86 and so on. So let's see. Kernel, let's look at kernel testing guide. This testing guide is in the kernel documentation. You can go take a look at that. And in docs, kernel.org, you'll be able to see it. Writing and it talks about writing and running tests and K-self-test versus K-unit, which one to choose and how to choose. So let's go a little bit into choosing framework. Well, first, think about what are your goals. Why are you running tests and why are you writing tests? Is it a regression testing? Is it a closed or open box test? Are there user interactions, user space interactions required to run the test? Is it unit test? Is it a unit test? Your answer could be K-unit or K-self-test. But if it is you're testing an internal API, it's K-unit. What does it require multi-arch support? K-unit, we are expanding multiple architectures. However, we don't have all of the architecture support yet. So you'll have to see if you require a specific architecture that you're testing on, does it have support for that in the K-unit? And code coverage. Also think about all of these things when you are choosing a framework to write tests in. So we have K-self-test, we have 192 individual make files, meaning when you go into the kernel self-test directory, you will see 192 make files. Each make file is specific for a subsystem. So we have 125 subsystem directories. So it is extensive suite. We keep adding to it all the time. So K-unit spreads across the kernel. It's like the code is around, it is all over the place, right? Spreads around. So you can, these are two commands, recent run I did with K-unit. You can see the runs. So that's how you will run it. A Python script runs a test. And in this example, I'm showing running all tasks on x86-64. So you can see that it ran about 6,701 tests, and it passed on that particular run. It passed 6,668, and there is a passed, and there is 33 skipped. So it skips a few for various reasons. You might not have compiled it in the right way, and the configuration option may not be selected when you are compiling it, when you are running the tests. Compiling the test. So, okay, your kernel configuration file, that is. So it prints out elapsed time and so on. So let's see what next. How do I know which which test to run for my specific use case. K self-test or K unit, you or both. So you decide based on what you're testing. And also, usually you start with K self-test, always, once you boot the kernel. And then once you could also run K unit. K self-test advantage is that you run K self-test while the kernel is running. So it can test the kernel as it is during runtime. K-unit, on the other hand, is a unit test. So it'll run through all of the unit tests in a virtual virtual machine environment, QEMU. It'll kick off a QEMU, you boot it, run all the tests, and it exits the QEMU. So it just depends on what your use case is and how you are going to run these tests. We have it's here. This is for your questions and discussion that we can have. Is there a support for expected fail and pass? If you are familiar with expected fail and expected pass, when you are writing a test, you can say this path is expected to fail and this path is expected to pass. In these cases, it'll look for the hardness. We have the hardness to test for those cases. So it'll say if a test is expected to fail, it'll check for that expected failure condition, and it'll check for expected pass condition. And we have references here. I have kernel references, kselftest.h and harness.h. The way we write kernel self-tests and KUnit tests is we make sure that if a particular configuration option is not supported, we have a configuration file associated with it. Each test, say test, say your test depends on huge table support. We have a config file under each of the test directories, so that specifies required configuration. And usually the recommendation is that when we are writing tests, we skip just the ones with unmet dependencies. The idea is that you run as many tests as possible. This is more for test writers at this guideline. When we're all test writers in the kernel community, all developers we write our own tests. As opposed to maybe if you're familiar with closed source software, you might have a testing team test writing team that does this separately, but we do writing our own tests. So guidelines are that we just skip the ones we absolutely must skip. So you have a test subsystem test suite that has 1,000 tests, and if only 2 of them don't meet the dependencies, then we run those rest of the tests and skip only those 2. So that is the guideline we go through by default. Okay, let's see. Yes, I am at the end of the presentation. I wanted this to be an introduction to the 2 kinds of frameworks we have in the kernel. And then if you have any questions, please feel free to ask me at this time.
Anyone has any questions?
And you can reach me on my LinkedIn or my Linux Foundation email or kernel email, shua@kernel.org. You can reach me.
Thank you, Shua, for your enlightening talk and for sharing your invaluable experience with us. Your contributions to the Linux community inspire developers around the world, and we are deeply grateful for your time and support for OOSC 3.0. Let's all give her a big round of applause.
So whenever you are ready, I think I have another talk coming up right after this. I can start that as well.
Yes, ma'am. So, would you like to share the screen for it?
Yes.
Yeah, okay, ma'am.
Okay, can you see the screen? Oh, you probably can. I think I see it in the window.
Yes, ma'am, it's up.
Okay, thank you. All right. So switching gears, I wear different hats. I am a kernel maintainer and developer. Also, I mentor people into the new developers, kernel developers. So in that role at the Linux Foundation, I oversee Linux kernel mentorship and an overall Linux Foundation mentorship programs. So I will talk about, I started this 6 years ago, and our goal is to empower open source communities. We'll talk about that a little bit. Okay, let's see. All right. Okay, we'll talk about the goals of this program a little bit, growing new talent and bringing new developers into the open source. It is challenging for new developers to engage with the open source communities. We'll talk about a little bit of that, and then what we have done in the last 6 years with this program, and then how you can participate in these programs. So we have so far, since we started in 6 years ago, 2019 is when we kicked off this program. It has grown, and we have gone from a small number of, if you look at just the kernel, we went from small number of 2 kernel graduates that year to we have gone to 50, up to 50, and this year seemed to be the biggest. I just took on 79 developers to mentor for fall. So this is our growth curve. We have seen 253 graduates last year, and 2025 numbers we don't know yet. But we have programs across several technologies: kernel, LF, decentralized trusted networking, blockchain, and so on, hyperledger and fabric, CNCF, and so several areas of open mainframe, for example, and risk, and so on. So we offer mentorships in all of these areas. And these are the numbers for our 2022 comparing with 2024. You can see that continuously we are growing our graduates. That means when I say graduates, really, those many new developers are participating in learning how to participate in various open source projects and participating in those. They have an opportunity to work mentored by experts in those areas. They will be the next generation that is to keep the open source healthy, and all of the open source ecosystem continues to stay healthy and sustainable, sustaining the open source. So you can, there's a few more numbers, but I'll get into various, we get lots of applications. We get like about thousands, 13,840 last year. And we are selective. We are limited by a couple of things: funds as well as mentors. We do not have as many mentors as we would like to add more programs. We're limited by those, but we take as many as we can in each of these programs. And so what we do after the mentorship, that probably is another indicator of how our graduates can be successful afterwards. Usually when a new developer engages with the kernel community or any other community, they get a lot of support. And once they graduate, they already have these connections, so it becomes easier for them to find a job and they are sought out by employers. You can find our graduates on our mentorship site. If you click on that link, you will see all of the graduates that from the inception of the project. Another opportunity is we have all of our graduates present. They present at open source summits. And recently, Open Source Summit in India, there's several graduates that came to do the presentation. We call them panels. We have mentorship panels. That's where they present their work, showcase their work. You can showcase would be we just had this one in this is the recent one in Denver that we had. We had one in Europe as well, Open Source Summit Europe in Amsterdam. We believe that mentees are future contributors and maintainers and leaders. And I myself was learning at one time. So I had mentors in the community, and I recognized that without mentorship and helping me learn kernel, getting into how to interact with the kernel community, I wouldn't be here today talking about this. So I understand the importance of nurturing and helping new developers get engaged with the communities, open source communities, so that we can keep the open source going. So this is the learning resources at the Linux Foundation. We have, you probably know about LF training site. We're calling that education. We changed that this year to a better fitting name. It's a LF education that encompasses education opportunities, learning opportunities. You can check that out. And then we offer lift scholarships for people to come in and attend open source conferences where you can connect with people. We have a lot of webinars. I touched on that webinars in the last talk. We have a K-self-test webinar, K-unit webinar. Not just that, we have several webinars on KSAN, for example, static and dynamic analysis tools in the kernel, Cochinelle, Smatch, and so on. And then MM, there are a few MM webinars in there, RCU webinars, and tracing, ftrace. And these are all webinars hosted by experts in the kernel community, maintainers and experts in the kernel community. Check that out, and you'll find up to maybe close to 100 of those available for you. As for mentorship programs, we also have speed mentoring events at the open source summits. And then as for mentorships, we offer both full-time and part-time, and they run year-round, spring, summer, fall. And some are paid and some are credit only. We actually pay for you to learn. And then our part-time, we don't have part-time in fall, but you can take a look at that, all of those. And mentors and maintainers hold up the pyramid. Really, this pyramid, it's vital for sustainable and healthy projects. We do that, and then we offer various programs. So mentoring benefits. Mentoring, for one could say, hey, how does mentoring benefit maintainers? They already have enough work on their plates. What it does is teaching and sharing experience. I find that when I teach and share, I learn a concept, a better, deeper understanding of the concept. That is the first benefit. And the other benefit is, of course, growing and strengthening projects and communities, because it is good to train new developers. If maintainers and experts in the community are training them, you are training them the training is coming from within. You're learning from people in the community as opposed to somebody else teaching you how to engage a community, somebody that does not know the community. So it also helps us. We can say, hey, we need this API changed a little bit, or across the board changes, or we want to fix bugs, documentation, and new features. We can get extra help for all of these things. So it does take, so it's kind of a double-edged sword. You are spending time to a new person to teach how to do something, which is always slower than you doing it yourself. But if we all did that, we would not have shared our experience with somebody, and we would not have the opportunity to get a deeper understanding of something ourselves. So it is important. It is like, hey, you're getting in the kitchen and your parents will say, hey, you slow me down. I'm not going to know how to teach you how to make cookies. So then you wouldn't know how to make something for yourself, right? So you do have to invest in the next generation. Benefits to open source communities themselves is strong. You will have strong and sustainable open source communities, and you will have improved security and quality releases. When somebody new comes in, they look at the practices or how we are doing things, or just the code itself with a new set of eyes. It's always helpful to have that fresh look at something that they can at times find things. That's one of the reasons why writers and everybody uses editors to go look at. Once you are looking at your own code, it becomes harder to find things in your code because it's so familiar for you. It's a muscle memory. You're working with muscle memory. Sometimes bringing in new fresh set of eyes improves security and quality of releases because they're using it in a different way. They're using the code or a feature, or they're just using different ways to test the operating system as well. So I say operating system because I'm a kernel, but in general it applies to all software. So we also provide a talented pool of prospective employees trained by experts to open source ecosystem, so which is helpful. I won't talk much about the program. I'll let our graduates talk about it. CNCF mentorship graduate said that it's a pivotal experience for their professional development. And another person said it's incredibly valuable experience that has broadened my technical horizons. That is key to me, because broadening technical horizons, especially if you are working you could be working, because our program is open for students as well as professionals. So say you're a student, you're focusing on getting your classwork done, you are exposed to things, you are working on getting your grades up or getting through tests, your exams and everything, but you might not go look at how industry works. So this gives an opportunity to broaden your technical horizons, in the sense of understanding what's new, what's happening, it's the nuts and bolts of technical horizons. So it helps you understand those. It gets you understand who is actually writing the code in these open source communities, working in those communities. So it helps, definitely helps there. And even for somebody, a professional that's working and focusing on their day job, this gives an opportunity to broaden and go and explore different projects, different technologies, and different code bases. And main thing is sometimes open source, participating in open source, each community is different. It is not like you can teach somebody how a closed source project works or a company policy works, but it is hard for people to understand open source when they are not familiar with it. Each community has its own dynamic. These programs help understand. They were people that are coming in, they have a mentor telling them how to work with the community. They guide you through working with the community. So that is different from, hey, just trying to do it on your own. So working with experienced mentors, we touched on that. Explore and learn together. So we touched on that as well. So this kernel graduate said that even with a limited experience, they could contribute to the kernel in meaningful ways. And then hands-on experience, large-scale real-world subsystems. So you cannot get any, if you look at the kernel code base, 2+ million lines of code that supports so many architectures, anywhere from a small IoT device to all the way to supercomputers, it is a unique experience to work with Linux kernel and be able to this large project with 10,000 developers, and being able to send patches and say, hey, I am here and I am sending this contribution to you for review. That first step is very difficult step. So being able to do that with mentors by your side is valuable. All right, you can read through these yourself. I uploaded the slides, but generally the summary will, there are lots of things. The things I will tell you, the ones that challenged me technically, that's another one. Deepen on my understanding of open source communities. Let me see, I'm going to, what are the takeaways? Let's get to the takeaways. Those are individual quotes, and takeaway is learning from experts and experienced developers, collaborating with experts in the open source communities, contributing to real world projects. That's an unique opportunity. If you know open source and probably most of you are familiar with open source communities, at least one or two. So, and when you do know, if you go back and think back and when you made the first contribution, how hard it was, it is a hard thing because you really don't know who is out there that is going to take your patch. So this is having somebody help you through that process definitely helps you, eases the some of the challenge of engaging the open source communities. And then it offers a personal and professional and technical growth. So when it came to personal growth, there is a quote in there that talked about how when they came in, they understood, they grew both personally and professionally as well, and technical growth, all three together. And there's one mentee that said they didn't know, they weren't very confident with communicating in English because it's a third language for them. This experience helped them immensely in growing there as well. You understand, personal growth comes from, you're working with strangers that have no obligation to take your code. They have, and they don't have an obligation to even review your code. You have to be able to communicate in a way you are making your case and saying how this new feature or new change helps not just you, the larger community. That takes a lot of communication skills. That's where the personal growth comes from, and as well as professional growth. So you will understand those things. Let me see. Okay, sorry, I am my mouse moved. Technical difficulties. All right, now I'm focused right. Okay. All right. So you can see okay. So let me see. Okay. Linux kernel mentorship graduate blogs. You can learn those. I'm leaving a link here for you to learn about what people have done, and CNCF. These are all the blogs we do after we end the sessions. And you could actually read people's personal experiences. That's always insightful. It gives you an idea of how the program works and what they learn what they learn during the screening process, and then what they learn during the program, and what they accomplished during that. So you can take a look at those. I'm going to leave those links. And then this blog about unlock growth talent, why maintainers should mentor. It's a CNCF. Nate Barrington wrote that. They talk about it talks about the importance of mentoring and why it's important for maintainers to take the time to mentor. And in this second one, I talk about behind the scenes of running kernel mentorship program. Then you can learn about the screening process and what's important. Say you are trying to put together a mentorship for yourself, so you can understand, hey, what all it takes to put together a mentorship program, how to think about designing a program from the perspective of a new developer that's coming in. What are they would like to know what they are going to learn when they come in. The first question is, am I eligible? Can I participate in this program? Do I have the skills to participate? Once you get into the program, what am I going to learn? And those are all the questions. How to design those, how to think about different aspects to think about. Okay, what does research show? So mentorships, what does research show in terms of my upskilling and such? So there is a recent Linux Foundation 2021 State of the Tech Talent report that came out, talks about how to retain talent. So it's always easier to upskill your employees than hiring new people. So what happens with this is upskilling means that you are, if you employer said, hey, we are going to help you upskill, that might be easier for employers than saying want to bring somebody that already knows an expert. So you can take a look at this. At the executive level, 62% longer to upskill. Onboarding takes a lot longer than upskilling. So that's kind of a message to employers, I guess, too, when they are looking at providing learning resources for their employees and having their technical talent upskill, as opposed to look for new people, onboard new people. Yeah, let's take a look at this survey for sure. This tech talent report. Relevant. So the new, this is a key takeaway in this survey that came out. Relevant hands-on experience people with relevant hands-on experience have 95% of the people that are getting hired on recently. So that is another key, that the importance of these mentorship programs and so on. Once you have hands-on experience, it becomes a lot easier for you to present your work, prove your work. Open source is different, right? Your contributions are public. One could go and check your contributions on GitHub or Linux kernel code, and you can just go check how many signed offs you have. So it's easier. So how can you help? Collaborate with us, bring project ideas and mentors and funds, of course. But these are all the components that go into it. So do reach out if you would like to collaborate. Project ideas are very important. Mentor time is important. And if you have a project that you want to, project ideas in any of the areas that I talked about. So I leave you with this quote. I am a Telugu speaker. So there is a Telugu proverb that says, "Andalunte kondal darvachu." That means that if you have support, you can cross mountains. It's better together than doing it alone. And here is discussion and any questions you might have. I can answer them now.
So, anyone has any questions?
All right. Looks like there are no.
Yes, ma'am.
Yes. Okay. I will stop sharing. Let me see where I can. Okay.
Thank you, ma'am.
Do I at this point remove myself from the stage, or would you do that?
I'll do, ma'am.
Okay, thank you.
Yeah. Sir,
Hello?
would you like to? Yeah, hello, sir.
So how to display my presentation?
So you can share the screen.
How to do it?
You'll see an icon of present or invite.
I don't understand. Should I wait for something or do something?
So have you mailed us the PPT, the presentation?
Yes.
Is it fine for me to present it if you are not able to do it?
I don't understand. What should I do now?
Please. Yeah, yes, sir.
So he should click here.
Like he has to do it. We wants to.
Yes, he has to click plus.
No, this one, present or invite.
Саша, смотри, там слева внизу есть надпись Present or Invite. Вот на нее нужно нажать.
А что-то ее не вижу.
Ну вот, ты видишь
Слева
внизу, где вот участники, один это вот, собственно, комп в этом зале, потом ты, а справа еще такая прямоугольник большой, Present or Invite.
У меня такого нету.
А может, у тебя на весь экран что-то?
Да.
Давайте сейчас
Это неправильно?
в Телеграм. Я сейчас в Телеграм себе фотографию пошлю.
Так, все, я понял.
Так, на всякий случай послал.
Так, это получается, я должен загрузить файл, да?
Да, PDF-ку сюда,
Я
и
вроде бы
там
куда-
будет кнопка ее пролистывания.
Сейчас. Потому что я куда-то его посылал.
А то на Gmail какой-то, они типа сами загружают,
Да-да.
а здесь тебе предлагают самому загрузить его. Чтобы ты сам его мог листать.
Так. Загружается.
So present copy. He's not able to present.
He's not able to present. No, he is uploading the presentation.
He's downloading.
Yes, already uploading.
Yeah, he's able to do it.
Да, вот появилась у нас презентация. А у тебя есть кнопка ее пролистывания, переключения слайдов?
Да.
Ага, все, хорошо.
Да, все.
I'm delighted to introduce Mr. Alexander, a respected project member and open source contributor. He is the author of IPP USP and Saint Airs Scan, widely used projects in the Linux and open source ecosystem, and has also mentored students through Google Summer of Code. His work demonstrates the true spirit of building impactful tools that serve communities worldwide. Please join me in welcoming Mr. Alexander. Over to you, sir.
Can I start now?
Yes, sir.
Okay. So now I'm presenting the behaviorally accurate simulator for multifunction printers and scanners. First of all, few words about myself. I'm the Open Printing Member since 2020, and I came here that author of Saint IRScan and IPP-USB. And historically, the very first issue against IRScan was sent by Thiel. And after that, we worked together on open printing. And IPP-USB was basically created as the answer to Thiel's question why IRScan doesn't work with printers connected to USB or IPP over USB. I write system software for years in C and Go. Author of IPP, USB, and IRScan packages, and you see my name on GitHub. And now I work as a member of team that helps to move the entire 20 million city from Windows to Linux. Mikhail was previously had a talk about this project. This is in short what we will speak about. Why do we need an MFP simulator at all? What does it mean to be behaviorally accurate? What's in the box, the scope of this project? How to write models, how to make them simple, because we don't want to re-implement the entire device in each the model. What tools exist to help with this work? The current project state, the future plans, and the project created as parts of this project. So why do we need MFP simulator at all? To develop drivers, to develop system software, it's important to have access to hardware. But printers are big, heavy, expensive. It's very hard to collect enough printers for all testings, for all development. Sometimes problem happens on a printer that I don't have physical access to. From, for example, in another country, I just receive bug report, email, and cannot reproduce the problem. So being able to simulate it, to reproduce the problem in the laboratory, is very important and helpful for this work. What's included? Printers are very complex. So this project is focused on simulating the standard-based open protocols like IPP, Internet Printing Protocol, EACL, and VSD scanning. At the USB side, IPP over USB, DNS-SD and waste discovery, advertising of devices, probably some semi-accurate implementation of legacy USB printing protocols will also be added just for completeness of the IPP over USB simulation. Proprietary protocols are not implemented, not planned, because they are not documented. It's very hard to simulate it. Protocol details are not known. The next question, what is behaviorally accurate? We have specification, IPP, EACL, VSD, defined by specification. And device offers, exposes its capabilities as printer attributes, as scanner capabilities, but it's not enough, because a real device behave differently from the specification. And this is a major source of problems. For example, printer may offer PDF support, but if you send more than 5 pages to the printer, it doesn't print. And it needs to be somehow reproduced. How accurate can be our models? Technically, it can be very accurate, but we don't know all aspects of device. So the actual limiting factor is what do you know about the device? But it's not so important because uh, actually we need to reproduce the problematic things. If we know that something doesn't work and we can reproduce, we can work on it. If our driver doesn't use some feature of device, we don't need to simulate it, and we can add the simulation later when it will become important for us. Well, the next thing, how to create model. Models are big, and creating them manually is hard work. So we have some helper tools. We have the MFP model tool that can snapshot device capabilities from the real hardware or from the simulated hardware, doesn't matter. And it create the model template. This model template is some idealistic view to the device. We can immediately use it for simulation, but it will behave correctly. It will not reproduce bugs. But anyway, it's a good starting point. And here I will show a small example. This is a fragment of Kyocera ecosystem scanner automatically created by MFP model tool. You see, it's just a set of parameters. And we can immediately load it into the simulator and scan from it. This is a real snapshot from my laptop. In the bottom right corner, you see the command line, how simulator is started, and Xane program windows that request scans and they received picture. It's a test picture that just embedded into the simulator. And simulator can as you can see, if you will look to the command line, I just typed the Xane command as a parameter to the simulator. This is very convenient because it starts the program and the simulator exits when program exits. And simulator sets environment variables so that CNR scan disables its discovery engine and directly speaks to the simulated printer. So it's very convenient for everyday work. Now, let's speak how we can add behavior details. The model itself is a text, and it's essentially a Python script. Although the simulator itself is not written in Python. So the printer attributes and scanner capabilities are just Python dictionaries. What we can also write Python functions, and simulator will call them as hooks. And these small or maybe not so small scripts can modify the actual behavior. They have all access to request, all access to response, can do many things, but you don't need to write everything if you don't want to change something. You only write hooks that you need. So let's see to the real example. The practical case. I had a scanner that offers JPEG and PNG image support, and AirScan always prefers PNG because it's lossless. However, actual device offered PNG but sent JPEG, even if PNG was requested. So it caused the image decoding error and forced me to implement image format auto detection inserts in the IR scan. Let's reproduce it on the simulator. We have a hook, and you see it on a screen on a top left corner. It's very simple. It receives the scan request and can modify it. So if PNG image requested, it can replace it with JPEG. And you see two fragments from the IR scan log, because it's not very visible in the result, visible only in log. The first one is without this hook, and the second with this hook. So we can easily see that actual image received is JPEG, not PNG. And another thing, we can also request some modification of generated image. I don't want to bring all the image into Python because it's big. It takes a lot of memory, so we have image processing pipeline which is embedded into the simulator, and Hook can instruct this pipeline to perform some modifications of image, and this modified image will be presented to the scanning client program. This is useful to emulate firmware bugs and to test drivers, because firmware often can return not what was requested, but something different. So let's play a little bit with it. This hook is called when image is ready, and here we modify the actual image resolution. Originally, image was requested by a scanning program at the 600 dpi, and we hack it to be 150. And simulator will resample image to this new resolution. And this is what we will get. Here, two snapshots from Xane. At the right side, this is image processing without the hook. It's a big image. It doesn't fit the window. At the left, at the right side, the same scan request, but with hook applied. So image shrinked to the next resolution, and now takes only a fraction of the window. And many things can be do this way. Actually, this near the full control to the image processing, and near every aspect of the simulated model can be modified this way. So small just a moment. So what we actually have now? We have the simulator core that provides an ideal, fully standard compliant based simulation of printer and scanner. And we have model parameters that define its work. It can understand and emulate any parameters. Simple hooks provided. So behavior can be modified on the fly. And this architecture makes our simulator both simple in use and powerful in what we can do with it, with that. Under the hood, the core simulator is a set of Go libraries, which provide high-quality implementation of all major protocols, and it can be used not only for simulation. It can be used as a generic implementation of IPP, ACL, VSD ads. For example, you can use it to write the cloud printing service that will work like a normal printer. Applications are just simple programs that add command line interface to this stuff. As all the functionalities in libraries, it's reusable in other projects. And this code base can serve as a foundation for other projects related to printing and scanning. Also, another useful thing that we have is the MFP proxy. MFP proxy can, the simple thing can move the external device to your local network. And it can sniff the traffic, so you can see the full protocol trace decoded in the textual form, and you can analyze problems you have. You can run some scanning or printing program under the proxy and see what actually happens between this program and scanner or printer or caps, and can investigate the problems this way. And it can also apply model to the real hardware device, so you can modify its behavior and its attributes. This is useful if you have some hypothesis that some aspect of hardware doesn't work. You can modify it and quickly test your hypothesis before you will go deeper to investigate how to work around the problem. This project also is very fruity to the various side projects created as a part of it. And here I will outline only a few of them. The project itself is large. It's not simple. It's not just a simple collection of Python scripts. It's about 50 lines of Go code and 26 thousands of lines of tests. And now I will briefly speak about other projects that were made during development and probably will eventually become the separate projects and will receive its own life. First of all, it's Go binding for Avahi. Avahi is the standard DNSSD daemon for Linux. There are other bindings exist, but my binding has a difference. It's very I thought it attempts to emulate to reproduce C API and Go as close as possible. This is idiomatic Go. For example, you don't have callbacks for events. It's very not typical for Go to use callbacks. You have channels, and you can receive events from channels, and this is useful because you can, in a single thread, receive events from multiple channels and process them together. And also, I have Avahi C API is not well documented. Many nuances are missing. So I have investigated it deeply and wrote very detailed documentation, which can be useful even for C programmers, because it documents many interesting nuances of Avahi API. The next project, sub-project, currently it's still a part of the main project, is this is the Golang binding for Python. I use the standard CPython implementation installed on any Linux host. And which I don't want to is to depend on the particular CPython version, because you upgrade your system, everything breaks. So this implementation links against the generic libpython library, and it survives minor upgrades. Python have stable stable API, and my binding uses only that. So it's tolerant to Python version upgrades. You don't need to rebuild applications that use it. Also, unlike other Python go to Python bindings, usually in the Python C API, objects are managed by object lifetime is managed manually. If you have received object from Python, you need to explicitly release it after use. But it's not convenient. Python is garbage collection language, and Go is garbage collected language. So in my binding, Go garbage collector manages Python objects at the Go side. The current project state. This project is work in progress. Not everything is ready yet. Most complete part is the ESA scanner simulator. It's almost complete. The VSD scanner simulator is performed by independent contributor Yogesh Singla. You see his name at GitHub, and probably half of VSD already implemented. And also partly done is the IPP support. It's done by me. We have also IPP over USB simulator, which simulates the USB device connected to the computer. You see it in the when it's active. You see it in the list of USB devices. It uses the USB IPP project for this work, and actually implements the USB IP server and Go. Its level of completeness is the proof of concept. It can simulate the device, but configuration cannot be set for now. Well, things that are not started yet are the DNS-SD and VSD hardware advertising. Future plan. First of all, I already use this project for my day-to-day work. I can reproduce useful things for CNR scan, and I can troubleshoot printing issue using the proxy, which performs traffic sniffing. The major part of this project, I hope I will be able to finish it till the end of this year. The next obvious direction is to create a testing framework to test printing and to automatically test printing and scanning on the simulated hardware. Now it's all optimized for manual work. I just manually start simulator and do some experiments with that. And integration, we also have another project which performs the CAPS filtering pipeline evaluation at the image processing level. It's done by Sanchkar Yaduka. Probably these two projects needs to be integrated so we can test just everything as a part of a single testing framework. So looks like that's all. Thank you for your time and attention, and I'm happy to answer any question.
Does anyone have any questions?
You can always contact me through Telegram, through my GitHub page. I usually answer to everybody. Everybody welcome.
Thank you for your talk. I have a question. How to your mind is automatic collection of device parameters and other information accurate? I mean, if you run the tool that collects all the information, how much manual work will be required to properly emulate a generic, a normal device? I mean, not something very strange, not, for example, Katyusha, but something like HP printer. I'm asking because if we have access to many printers in many places and can, for example, try to automate collection of this information, will how much manual work will each printer require?
It depends on device, from 0 to weeks. If device behaves very close to specification, nothing additional work is required. The model represented accurately. But if there are deviation, the measure of effort is to discover these deviations. Implementing this cell.
So discovering of deviation is not automated.
Yes.
I see.
Usually it happens by itself. Usually it doesn't take too much time. Your printer doesn't print. You look to it. You have some hypothesis. You can very easily try it on the simulator. So in most cases, deviation for each particular device, deviation is small and simple, but it breaks something in the stack.
Yes, but the
for
problem
example,
is that you will have to find them for each device manually. Probably.
To discover everything, it's hard work, but actually you need to discover only things that affect your client software. So it's not so important. Usually it hits you and you see it. Which the workflow I hope on is when a user comes to me with problem, he can make the basic model by itself and send it to me. And maybe I will tweak it a bit or ask him or her to tweak it a bit. And within a few days, we will have the problem reproduced. This is how I see the perspective of this project.
That would be very nice to be able to test printing subsystem of the operating system without access to real hardware. At least test it a bit. Much better than nothing.
Let's see how it will work in the real life. It's we only begin to use it in the real life. Let's see. When we'll get some experience, we will know better. Did I answer to your question?
Yes, thank you.
Anyone else has any questions? Thank you, Mr. Alexander, for sharing your insights and experiences with us. Your journey and contributions are a true source of inspiration for the open source community and for the students here at OOSC 3.0. We are grateful for your time and support. Let's give him a warm round of applause.
Thank you very much.
Thank you, sir.